Welcome to this Lexical iOS video session. Today we'll be talking about how to control the typography of the text that Lexical renders. We'll discuss how Lexical iOS thinks in terms of NS-attributed string attributes, in contrast to Lexical Web, which uses CSS. We'll look at how Lexical decides which attributes to apply to each piece of text. We'll discover how to build a theme to easily customize the display attributes without the need to subclass any nodes. We'll talk about how to work with attributes if you are building a custom node. And finally, we'll talk about how you can use custom attributes to communicate with your own custom drawing plugins, or to allow your users to provide theme information for your custom decorator nodes. First, a quick recap about TextKit. Lexical is based on TextKit 1. This is the text rendering framework that grew out of the text APIs used in NextStep and OpenStep throughout macOS 10 and came to iOS first in iOS 7. Although Lexical abstracts away much of TextKit, it's helpful to understand what's going on below the surface. TextKit has three main classes that work together to provide text rendering. The NSText container represents a region in which to draw text. The NS Layout Manager is the brains of the operation, taking some text content, laying it out into lines and paragraphs, calculating which glyphs to draw, and caching everything to minimize the number of calculations in the future. And finally, there's NSText Storage, the data model that contains the rich text that the Layout Manager will be drawing. Here's a secret. NSText Storage is actually a subclass of NSMutable attributed string. For the most part, you can treat it just like an NS-attributed string. If you've done iOS development for a non-trivial amount of time, you'll certainly have come across attributed strings. They're the platform's native way of representing rich text. They combine a string with a whole bunch of attributes and ranges. But what are these attributes? Quite simply, they're key-value pairs. Apple define a bunch of attribute keys which TextKit knows how to render, such as font, foreground color, shadow, underline style, and so forth. So for the font key, you would provide a UI font value. Thus, if you are working directly with an NS-attributed string, you might want to apply the font key value pair to the first four characters in the string. That's how attributes work without Lexical. But with Lexical, you don't ever interact with the attributed string directly. This means you don't need to do all the maths to work out ranges. Instead, each node provides its own attributes via the getAttributedStringAttributes method. In that method, the node returns attributes that are applied to all the node's content. You can't do something like apply bold to the first four characters of one single node's text. If you wanted to do that, you should split your text up into two separate nodes. Lexical's nodes form a tree structure. So to work out the final set of attributes that should be applied to a character range in the output, Lexical considers the node in question plus all of its recursive parents, right up to the root node. Lexical does something akin to CSS's inheritance. If the deeper node in the tree does not specify a value for a certain attribute, it uses the parent node's value. But if the value is specified, it overrides what the parent had provided. For example, if your paragraph node is providing a font attribute, then that font attribute gets applied to all the text nodes inside the paragraph too, unless those text nodes override the font attribute with a different value. I'd just like to clarify, nodes provide their own attributes. You don't set attributes on an instance of a node, so if you're making your own node subclasses, you can use whatever logic you want to derive the attributes. But if you're working with Lexical's built-in nodes, you can't say, this paragraph should have attribute A, but this other paragraph should have attribute B. With the built-in nodes, you can only say, all paragraphs should have this set of attributes. And the way you specify that is through the theme. That's enough theory. Let's put this into practice. First of all, let's look at how you build a theme and what it can do. A theme is passed to the Lexical editor on initialization. It lives inside the editor config, along with the plugins that will be used by this editor. So let's start by instantiating a theme. Within our theme, we can specify attributes for use by any node type. Suppose we want every list item to have red text. We might do something like this. When we specify theme.listItem, this is referring to the node type of listItem node. You can set attributes for any node type on the theme. One thing to be aware of is it is the node's responsibility to pull information from the theme. The theme object is passed in to get attributed string attributes. In this case, the built-in listItem node does indeed pull information from the theme, so we're fine. But if you were using a home-built node, it will only pull information from the theme if you write the code to do so. Next, let's specify a font that our whole document should use. We can do this by applying attributes to the root node. Here, we're setting a font on the root node. Since every node in our document is a child of the root node, they'll all gain that font too, unless they override it. Now, let's style a heading. In this case, we don't just set attributes on theme.heading. This is because heading node has a bunch of different heading levels, and you will want each of those to have a different set of attributes. In this case, we use the theme API setValueForSubtype. We're passing in our node type as the first argument like usual, and then we can fill in the second argument to specify that we're styling an H1. In this case, we want our H1 to have a larger font than the main text of the document. You might notice we're repeating ourselves here. The font attribute key takes a UI font value. A UI font encapsulates the typeface, size, font weight, etc. So we have had to specify the San Francisco font twice. Lexical has a solution for this. As well as the attribute keys provided by iOS, there are a bunch of lexical-specific attribute keys. In this case, we can use the font size attribute key. If we do this, Lexical will adjust the font size, but keep the same font that it inherits. Let's put that in our headings attributes dictionary, and we now have the same result, but without needing to repeat ourselves. Another useful attribute provided by Lexical is text transform uppercase. This should be familiar to you if you work on web technologies. On iOS, TextKit does not offer a way to make text uppercase without mutating the actual underlying string. But with this attribute provided by Lexical, we can make our headings display as uppercase, while the backing storage of the text will remain as the user entered it. This means that if the user changes to a different heading style, the uppercase transformation is removed and the text is exactly how it was before. There's one more custom type of attributes that Lexical supports. It's called block-level attributes. To explain what it is, we need to talk about why it is needed. Suppose you had a node like a code node or a block quote node. You might want to leave some additional vertical space at the start or end of your block quote, like a margin. But you don't want to apply this extra vertical space to any line breaks that happen to be in the middle of your node. This sounds like it should be easy. And to work out why we had to build a special system to do this, we need to look at how TextKit's paragraph styles work. In TextKit, the easiest way to add vertical spacing is to use the paragraph spacing or paragraph spacing before properties. But they apply spacing to every paragraph they encompass, and TextKit's definition of a paragraph is the text between two line breaks. So with our block quote, what we want to do in TextKit terms is to apply some paragraph spacing before to the first paragraph within our block quote, and apply some paragraph spacing to the last paragraph within our block quote. Lexical can do this for us. Using the theme, we set the block-level attributes for our node type. The block-level attributes apply to your whole node, and Lexical takes care of setting the correct TextKit attributes in the correct place to accomplish the effect that you want. Now we'll quickly cover how to work with attributes if you have a custom node. We touched on this before when we mentioned the getAttributed_string attributes method, but now we'll talk about how you implement this within your node subclasses. The simplest thing you can do here is just return a dictionary of attributes. It can be empty if you just want your node to inherit whatever it is contained in. Or you can return specific attributes to override. In all cases, if a parent node specifies an attribute that you do not specify, then the parent node's attribute is used. You will probably want to pull attributes from the theme. To do this, you can use .syntax with your node's type on the theme. This is the same syntax that users will use to set the theme's attributes. Make sure that you have some kind of default values, just in case the user has not set any attributes for your node type on the theme. If your node has multiple different ways it can look, similar to our heading node, you could use subtypes. In this case, use whatever internal logic you want in order to decide which subtype to fetch, and then use the getValueWithSubtype method to fetch the values from the theme. It is rare that nodes will need to customize fetching of block-level attributes, although you may want to supply a default value. If your node concerns itself with block-level attributes, you can override getBlockLevelAttributes. The default implementation here just pulls directly from the theme, but your node could supply custom values here if desired. Last but not least, let's briefly touch on the custom drawing and custom decorators. These will be covered at length in a separate video, so I'm not going to teach you how to build these, but I am going to touch on how attributes are used here. Custom drawing refers to drawing behind, around, or on top of the text in your node. It doesn't affect the text layout, but it gives you access to core graphics APIs to produce a custom look. For example, a quote node may use custom drawing to display a vertical bar in the left margin. The custom drawing handler does not change the size of that margin to make room for the vertical bar. That is done by some other method, such as increasing the indentation level or setting padding head, both of which are lexical custom attributes. To teach Lexical how to draw the vertical bar, you need to make a custom drawing handler. This is a closure that is passed a bunch of parameters regarding the metrics of where the text will be drawn, and within that closure you can draw using core graphics. Then you register your closure with Lexical by calling editor.registerCustomDrawing. You pass in your custom handler and a few options, and you also pass in a custom attribute key. This custom attribute is how Lexical knows to apply your custom drawing. You need to make sure that your node sets a value for that custom attribute inside getAttributed attributes. It doesn't matter what the value is as long as it exists and that it is an Objective-C compatible object or primitive that bridges to an Objective-C class. This restriction is important because TextKit internally compares attributes values using Objective-C's isEqual. Putting a Swift struct, for example, inside an attribute dictionary could lead to unexpected or undefined behavior. The custom attribute for which you have registered your drawing handler, along with its value, is passed into the handler itself. So if your node needs to communicate any data to your drawing handler, that data should be put inside your custom attribute's value. Within your custom drawing handler, you do not have access to the node object itself, so this attribute is the only way that it can obtain any data it needs. Another use for custom attributes is for styling a custom decorator node. A decorator node in Lexical iOS lets you embed an arbitrary UI view within the text. Custom attributes are really useful here. For instance, when we were making table node, we wanted to allow a user to set a background color and a border color through the theme. Apple already provide a background color attribute, so we used that. But we decided to add a custom border color attribute. Just like before, we added our attribute by extending nsAttributedString.key. This time, we read our attribute from the theme in the createView method, which is where a decorator node's view is created. The theme isn't passed in as a parameter to this method, so we have to get it from the active editor. Once we have retrieved the theme, we can read values out of it just like before, and we can use these values when constructing our decorator node's view. Time to wrap things up. Let's review what we have learned. We've discussed how TextKit uses attributes and has a selection of built-in attributes that it knows how to render. We discussed how Lexical applies attributes at a per-node level, and that nested nodes will inherit their parents' attributes. We learned how the Lexical theme allows configuring the look and feel of Lexical nodes without having to subclass them. We learned about some attributes that are built into Lexical. We discussed how to implement getAttributed-string attributes when building a custom node. And finally, we discussed some situations where you might want to define custom attributes for custom drawing or for custom decorator nodes. There was a lot of content in this session, as attributes are fundamental to Lexical iOS. They're also one of the things that is most different between Lexical Web and Lexical iOS. I hope this talk gave you a good foundation of the concepts. As usual, you can get some more detail by reading the Lexical iOS documentation, especially the sections on theming and creating nodes. Thanks for listening and goodbye.